It's all important, but this is for you, Gilchrist. Okay, this one's dedicated to you and you. Anyway. Yeah, exactly. Well, here we go. Now, gentlemen, listen to this. This question. We've got 4 points, and we need to work out the coordinates of intersection. Whenever you see intersection, the word intersection, it should, in your head, shouldn't take long, you should think simultaneous equations. Intersection of lines, or an intersection of a line and a curve, simultaneous equations. And straight after this, it's triggered that simultaneous equation thing in your head, you should think graphics calculator, because it does all those for you. Okay? So we don't have to do simultaneous equations by hand. The graphics calculator does it for you, but we have to know that simultaneous equations are involved in the first place. So here's the dots represent the points. So you just do a rough sketch, okay? Very rough sketch. A is 2, 2, so there's our point A. This is, of course, our origin, hardly needs labeling. C is over here, and this guy is B, and it's negative 2, 4. And in the previous question, and again, this assumes that you got it right. Clearly, if you got part B wrong, which was find the equation of the line joining AC, if you got that wrong, then it's going to make this question a bit difficult. So there is a bit of follow-on there. So let's just go back to, we can't go back because I didn't write it down, but what was the answer to the equation? In fact, I'll quickly do the equation again. The gradient of A to C, this is part B, by the way, is 2 divided by 8. Okay, we did that 2 divided by 8 thing. And therefore, y minus 2 equals a quarter x minus 2. That's using the equation y minus y1 equals mx minus x1. Substituting in, timesing by 4, we get this. Rearranging, we get this. X minus 4y. So that is one of our lines. Now, it just turns out that our next question asks for the intersection of those two, okay? Because the diagonals of our quadrilateral. Now, AC, the line AC, and I'll actually put it back there. So AC looks like that, and the equation is this guy, and BD is this guy, which I'm just going to, BO, you're quite right. And that green line, we haven't got the equation for yet. So basically at this point in the question, before we can solve those two dotted lines simultaneously, we need the equation of the other thing. But BO, unfortunately, maybe I should call it OB from now on. The line OB, because it passes through the origin, it's going to be y equals something x. That's the equation. And all we need to know is work out the gradient. But very easily, looking at the point negative 2, 4, the gradient is 4 over 2, negative 4 over 2, which is negative 2. So straight away, without any real working at all, the equation of the green line must be that. From elementary sort of year 10 or year 11 graphing, a line that goes through the origin has no plus anything on the end. It's just the gradient with an x. Okay? And another way of writing that is 2x plus y equals nothing. Don't need the other formula because, well, we could use the other formula, but as I say, any line passing through the origin is y equals gradient x. That's all it is. It always is the same. Because the zeros all, the x1 and the y1 in our formula, so that negative 2 and that negative 2 there, they would just be zeros, and so it would just be that. So the question didn't ask for what are the equations, it said what is the intersection. So what we do now is we get our graphics calculator, and I'm going to very quickly sketch these. This is x minus 4y and a 6. And I'll show you in a moment. 2x plus y equals 0. So there's our two equations. We're going to take this one here. Oh. Yeah, flash pen. Let's just try that again. That's working well. That's a pen with a mind of its own. Let's just go back here. Wasn't you, Gilchrist, was it? Okay. Didn't think so. Maybe a bunch of smiley faces will be easier. So, yeah, that's really flash. Okay. I'm not even going to do that anymore. So, x minus 2y plus 6 and this. So what we do is we go to our graphics calculator, which looks like this. We push the equations button. You can do this as well if you like. You push the equations button, which is on mine A. Where's the A? There. We get equations coming up on the screen. It says select type. F1 says simultaneous. That's what we want. Push F1. Then it says number of unknowns 2, 3, 4, 5, 6. 2 because we've got x and y. We're only doing two-dimensional ones, so we push F1. And then it says A, B, C. Here it is here. At the top, it's pretty hard to see, but that says A n x plus b n y equals c n. In other words, the equations have to be in general form. That means x's, y's equals numbers, not quite like we've got it. So notice the number is on the right-hand side of the equal sign. So for ours, we've got x minus 4y plus 6 equals 0. If we take the 6 and move it to the right-hand side, it becomes negative 6. So we will put in a 1 for our first equation and push exe. So that's a 1 because we've got 1x in our first equation. Negative 4 exe for our second one. And negative 6 for our third. Because, of course, our 6 has to go to the right-hand side, negative 6. So it doesn't want general form. It actually wants that number to be by itself on the right-hand side. And the next row, we put 2, 1, and 0. And then we push solve. And it gives us negative 0.6666. Which obviously means 2/3, but the markers allow that. And it even puts negative. This calculator converts it into a fraction, which is really nice. And y is 1 1/3. Now, so basically, our answer to the question is, we go back to, so our calculator has done what would be a little bit tedious because of the numbers. It's come up with negative 2/3 and 1 1/3 as the answers. So we would write down, going back to here, this battery could be running out, of course, that's always another one. So the answer to our question the lines, that says lines, L-I-N-E-S, intersect at negative 2/3, comma, positive 4/3. Or you just write down the decimal equivalent to 3dp. That was the 1 1/3 that we got on the calculator back here. That's 4/3, okay? So, or, well,
so this is the same calculator as yours,
yeah, yeah. 1 1/3 is 4/3. Now, if you want to just be safe and don't want to, you know, I mean the calculator, if I move this down to here, got to use this probably, there it is. It actually tells you 4/3. Now, if you want to be safe, just write down what the graphics calculator says. Negative 0.666 is technically not correct because the next digit is going to be a what? A 6. If this recurs, 0.6 recurring, then if we round it to 3dp, we need to really round that last digit up by 1. Okay, but it's not about rounding and stuff in this, it's about coordinate geometry. So in this particular situation, you could write down the fractions which are better, or I actually noticed in the answers that they allowed all sorts of variations like 0 minus 0.66, comma 1.33 was, that's a tick, was apparently okay. Some of these things have sort of been lost. In the old days, you were, because everything was given a mark, just little sort of errors like that would have been penalised because we were quite pedantic in the old days about rounding and stuff like that, because it isn't 0.66. Okay, it's actually 0.67, which is different. So you could say, well, you know, get it right or you'll lose a mark. Now, the marker is looking for you to be able to do the coordinate geometry and write down whatever the calculator generates, and that's fine. So either of those would do. I would personally expect most of you to probably write down this minus, because this is what the calculator told you. 3dp, if the calculator gives you that, and you write it down as it is, you're certainly not going to be marked wrong. Okay, so that question for merit, let's just, for merit, basically a sketch to get an idea of what's going on and using our graphics calculator to solve the simultaneous equations. Okay, so quite a reasonable amount of effort, but the fact that the first part of it was actually the other question, meant that all you had to do was identify the equation of a fairly easy, that green dotted line is a very easy equation, and use your graphics calculator. It's pretty basic, really. Okay, so the reason why I wanted to show you these today was to just show you the standard. Okay, the standard, even though it's a new and it's going to be internal this year, there's a whole bunch of things that you have to be able to show us you can do at the achieve level, but there's a little bit more application at merit and excellence. That, in other words, you've got to be able to apply some of those things. Yeah.